All right. So in this example, we are going to see that we are going to prove that local bridges are weak tie. Okay. Now we saw different definition, some of also from our intuition and experience from our real world, that the friendship can be strong or weak. Okay. Now from the graph theory we saw two definition, that a bridge or local bridge. Bridge means a edge, if removal of edge is going to partition the whole network, that means it's a bridge. But we saw that in real world bridge is not that common. Rather we can have some local bridge. Local bridge means removal of a, so in that case we can say AB is a local bridge, because removal of the edge AB is going to actually increase the path between A to B. Okay. And local bridge is the edge that is going to, removal of this edge is going to increase the path between A and B, and the path between A and B after removing the edge has to be at least greater than 2. Okay. Now from the graph, given a graph, we can actually prove that the local bridges are weak ties. Okay. All right. So how we can prove that? We are going to claim that if node A satisfies strong triadic closure and is involved in at least two strong ties, then any local bridge adjacent to A must be a weak tie. So let me repeat that again. So what it is saying, that if there is a node A satisfy a strong triadic closure property and is involved in at least two strong tie, then any local bridge adjacent to A, for example here AB, all right, any local bridge adjacent to A must be a weak tie. All right. So remember the strong triadic closure property. That means if A has a strong friend with node P and A has a strong friend with node C, then there has to be a connection between B and C. Okay. Now we are saying that all the local bridges are weak tie. So if A satisfies strong triadic closure and is involved in at least two strong tie, so in this example, if A is involved in at least two strong tie, okay, then any local bridge adjacent to A must be a weak tie. So we are saying that if there is a local bridge adjacent to A, all right, that is cannot be a strong tie. All right. So we are saying that any local bridge adjacent to A is going to be a weak tie. All right. So how we can prove that? We are going to actually prove that using a contradiction. Okay. So we'll say that A has a two. A is not violating strong triadic closure property. All right. And first we are going to assume that the local bridge adjacent to A is a strong tie. Okay. All right. So in this example, let's look at this example, and here we have this node A, and A has we are assuming that A satisfies strong triadic closure property and has at least two strong tie. So A has a strong tie with C and A has a strong tie with B. Okay, and we assume that A doesn't violate strong triadic closure property. All right. Now now we are going to say that if there is a local bridge adjacent to A. Okay. So if there is a local bridge adjacent to A. Okay. So let us assume that AB is a local bridge and AB is a strong tie. So we say that AC is strong and AB is strong. Okay. So if AC is strong, if AC is strong and AB is strong, then according to the strong triadic closure property, there should be a edge between B and C. Okay, so let's assume there is a edge between B and C. All right, so what we are saying that AB is a local bridge, but AB is also a strong tie. Okay, now by contradiction we are going to prove that if AB is a local bridge, AB cannot be a strong tie. Now for now we are assuming that AB is a local bridge, but AB is also a strong tie. Okay, so if that happens, then if AB is strong and AC is strong, so there must be a connection between B and C. All right, otherwise A will violate the strong triadic closure property. Now if there is a edge between B and C, in that case what happens? So if there is a edge between B and C, that means, now look at this graph. So what do you think? Now if there is a connection between B and C, now AB is not a local bridge anymore. Okay, so it's not a local bridge anymore. So it's saying that, what we are saying that if AB is a local bridge, we are assuming that AB is a local bridge and a strong tie. Okay, but if A is maintaining the strong triadic closure property, so by using the contradiction proof, we can prove that if A is maintaining the strong triadic closure property and AB is a local bridge, okay, AB cannot be a strong tie. Okay, so here let me go over again. AC is strong, AB is strong, and AB is a local bridge. So according to the property, there should be a connection between B and C. Now if there is a connection between B and C, AB cannot be a local bridge. So by definition, AB cannot be a local bridge, because just delete the edge. All right, so if we just delete the edge, the distance between A to B has to be strictly greater than 2. Now if we delete the edge, the distance between A to B is here, A to C and C to B, which is equals to 2. Okay, so we can say that AB is not a local bridge anymore. So by using the contradiction property, we can say that if A is satisfying a strong triadic closure property, all right, and A is involved with at least 2 strong tie, then any local bridge adjacent to A is going to be a weak tie.